Good morning, this is Kavi Priya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic gradient from the subject electromagnetic fields. So before starting with the presentation, let's recall about the coordinate systems. We have discussed about the coordinate systems in the last video, which is mainly used to locate a point in a space, and it is used to describe the variation of the field in different directions, and it is used to simplify the complex equations. So we have discussed about three coordinate system: Cartesian, cylindrical and spherical coordinate system. So it is a standardized framework for defining a point in a space. I am going to discuss about the concept of gradient and what is its role in electric and magnetic field, and finally about the applications of the gradient. So why this gradient is being used in the electromagnetic field? So we all know electromagnetic field has both the electric and magnetic field. The field varies with position and as well as the time. So we require a tool for describing these variation of the electric and magnetic field. So the tool is nothing but it is a gradient. So gradient is one of the vector operator which is used to determine the field variations, both the electric and the magnetic field. So gradient is a vector operator. It is denoted as nabla. Gradient is get applied to a scalar function. So gradient of a scalar is nothing but it is a vector. So by using this gradient, we can determine the direction of the maximum increase, and also we can determine the rate of change of the scalar. So rate of change and as well as the maximum direction, the increase in maximum direction can be determined by using this gradient. And this is the mathematical expression for gradient. So this phi of xyz, the equation is for a Cartesian coordinate system. So phi is a scalar. So the vector operator is applied on the scalar phi. So the result will be getting it as a vector. So gradient of a scalar is a vector. So the unit depends upon the scalar quantity. And next is a gradient of the scalar potential. So electric potential is determined by V, which is nothing but it is a scalar quantity. So now we are going to apply the gradient on the scalar, gradient on the electric potential. So the result will be getting the electric field. So E is equal to minus del V. The negative sign indicates the direction of the decreasing potential. So this E is equal to minus del V give the relationship between the electric field and the electric potential. And next is a physical significance of this gradient in electromagnetic field. So this gradient is used to determine the direction of the maximum increase of the potential, and it is also used to determine the rate of change of the scalar. So it is used to determine the magnitude of the scalar, and it is used to visualize the field distribution. And next is a curiosity challenge. First one is a odd man out. Among gradient, divergence, curl and Laplacian, gradient is an odd man out because gradient is a vector operator, operates on a scalar. Others one operates on a vector, or it is nothing but it is a scalar operator. Second one is an unscramble. Answer is a gradient. The gradient is a vector. It is a name given. It is a vector operator that points in a direction of the steepest ascent of a scalar field. Third one is a riddle. I am 0 inside the perfect conductor, which is nothing but it is a gradient of a potential. So the gradient of the potential is 0 inside a perfect conductor. And next is a gradient in different coordinate systems. So we have discussed about Cartesian, cylindrical and spherical coordinate system, and the gradient has different equations has been there for gradient in different coordinate system. So the gradient varies with the coordinate system, and used geometry on different expressions will be there for different coordinate systems. And next one is the applications of this gradient. It is being used to determine the field, and it is used for dielectric analysis, and it is used in transmission line field distribution and electromagnetic wave propagation. And this is a summary of what we have discussed. We have discussed about what is a gradient, what is the role of gradient in electromagnetic field, and we have discussed about this gradient of a scalar potential, mathematical expression for gradient, and finally about the different equations of gradient in different coordinate system, and finally about the applications of the gradient. And next is the assessment. Which of the following is not true for gradient of a scalar field? The answer is option C. Del f is equal to 0 implies f is maximum is not true for the gradient of a scalar field. The gradient of a scalar field f of x comma y comma z represents the maximum rate of change of a scalar and as well as the direction in which the maximum change occurs. So we have discussed about the gradient. Thank you all.